Good morning, everyone. For those of you who don't know me, my name is Scott Oakley. I'm the technical manager at Glasscorp. In this webinar, we will be taking a closer look at some common sealant technologies and chemistries, just explaining their advantages and limitations, and discussing some important properties of sealants that you should be aware of. So hopefully by the end of this presentation, you'll have a broader understanding of different sealant technologies, making the job of selecting the right sealant for your application a whole lot easier. Okay, so just a brief run through of what we plan to cover in the next 30 minutes or so. So firstly, just a very basic introduction to sealants and common applications in our industry. Then we'll move on to aspects of sealants, sealant chemistry, detailing the differences between some common sealant types, after which point we'll discuss a few important factors to consider when selecting a sealant for an application. And finally, we'll wrap up with a brief run through of key sealants in the Glasscorp offering. And at the end of the presentation, there should be a few minutes remaining for some Q&A if anybody has any further questions. So let's jump straight in. So starting with the basics, what is a sealant? Now, essentially a sealant in its most basic definition is a material used for sealing something to make it airtight or watertight. Now, in the construction industry, sealants may be used for a variety of other functions as well, including to prevent the penetration of dust or contaminants, to act as barriers to sound, or to prevent or impede the propagation of smoke or fire. Sealants that are used for the purpose of permanently bonding two materials together may be referred to as adhesives, or you may see these referred to as structural sealants. The distinction between sealants and adhesives, or weather sealants and structural sealants, is an important one to make. For instance, there may be many applications where it might be perfectly acceptable to use a structural sealant in a weather sealing joint application, but you would not use a weatherproofing sealant for a bonding or structural application. At Glasscorp, we supply a wide range of sealant products to the glazing and construction industries for a wide range of different sealant applications, a few of which are shown here. The properties that you require from a sealant might be very different depending on your application. So take, for example, a small joint sealant used in the fabrication of aluminium window frames. In these applications, joint sizes are minimal and any expected joint movement is low. So as a result, for this type of application, you wouldn't require a sealant with a high movement capability. On the other hand, for an air seal or an expansion seal, you might need to design for high thermal or seismic movements, in which case you may select a sealant with significant movement capability. Certain applications may call for a specific sealant type, which must be used. Other applications may allow you to consider several different sealant options to determine what product works best for you. In this next section, I'll just cover some of the basics on sealant curing technology and some common sealant chemistry types and their different properties. Generally, sealants can be classified as being either one component sealants or two component sealants, or you may hear them be referred to as one part or two part. This relates to the curing system, or in other words, by what means the product transforms from a flowable, gunnable sealant into a solid rubber-like material once it's cured. The most common one component sealants are what we refer to as moisture cure sealants, or RTV sealants. Now, RTV stands for room temperature vulcanizing. These sealants cure from a chemical reaction that takes place after the sealant is exposed to moisture in the air. Moisture cure sealants cure from the outside in, which means they must have adequate exposure to air in order to fully cure. If the sealant is installed in an area that is closed or sealed off, this can greatly slow down or even prevent the complete curing of the sealant. When it comes to one component sealants, the speed at which the sealant will fully cure will also be highly dependent on the size and depth of the joint. So for this reason, overly deep sealant joints should be avoided for one component sealants. The cure rate for one component sealants can be accelerated by increased temperature or humidity. And one component moisture cure sealants offer some ease of preparation prior to installation. There's no need for any mixing or special equipment. You could use standard cartridge or sausage guns to apply them, making for easy application. Two component sealants are comprised of a base component and an activator or catalyst. The chemical reaction that takes place when these two parts are combined are what initiate curing. They don't require exposure to atmosphere as they cure from the inside out. Some key advantages for two component sealants are they allow for significantly faster curing than single component sealants. Because the sealant cures evenly throughout the mass of the sealant, they can be used in larger and deeper sections than some single component sealants. For certain products, the ratio between the base and the catalyst can be adjusted to accelerate the rate of curing. So for example, increasing the quantity of catalyst to increase the speed of cure. Some considerations for two component sealants are that they do require the use of special mixing equipment. So this may be in the form of mixing pumps or special dual cartridge or applicator guns. Because there are two separate components, there is a little bit more room for error as well. So more attention must be paid to QA when using two component sealants. VOCs. So what are VOCs? You may be familiar with this term, or you may have heard it when used to describe properties of sealants before. VOC stands for volatile organic compounds. These are chemicals which are able to evaporate at room temperature, potentially affecting or compromising the surrounding air quality where they're used. They have been found in numerous different consumer products, including paints, cleaners, detergents, cosmetics, as well as sealants and adhesives. VOCs are used as solvents and sealants to help bind components together, allowing for adhesion to various building materials. They're normally measured and presented in grams per litre. And generally, VOCs are coming under increasing scrutiny and regulation. So there's a growing requirement for products that are designated low VOC. Different sealant technologies will inherently have different levels of VOCs. Some newer sealant technologies will often be engineered to minimize or eliminate the use of VOCs wherever possible. Before we jump into specific sealant chemistry types, I'll just cover off another term you may have come across, and that is reference to a sealant being organic or inorganic. But what does this actually mean? Now, I don't intend on doing a deep dive into the intricacies of organic and inorganic chemistry. I'm not qualified to do that, but generally at a fundamental level, organic sealants are comprised of a polymer backbone based on hydrocarbon-based polymers. So these are chemical compounds made of hydrogen and carbon. Organic sealants will always contain carbon. Inorganic sealants, on the other hand, don't have a carbon-based chemistry. These are based on materials such as silicates, aluminates, and sulfates. Chemical bonds that are used in inorganic sealants, silicones being our best example, offer superior resistance to UV and aging than those used in their organic sealant counterparts, which can degrade and break down over time. There are a wide variety of sealant options available on the market, each with its own advantages and limitations. A good place to start is understanding some of the basic sealant chemistries and the typical different properties of each. On this slide, I've listed 6 common sealant types, which you might come across. Sealants like polysulfide, which have excellent resistance to water and very good adhesion to different substrates, including glass. And we supply polysulfide for use as a secondary sealant in double glazed window manufacturing. A limitation of polysulfides is that they produce high VOC content than some other sealant chemistries. Rubber-based butyl sealants, which are permanently elastic and have excellent resistance to water or gas penetration, a reason that they're also used in the manufacture of double glazed windows. A limitation of butyl sealants so that they have a stringier consistency, which can make them a bit trickier to apply. You have acrylics. So these are economical water-based sealants with good resistance to weathering. And like many other organic sealants, they have the advantage of being paintable. On the other hand, they tend to have limited movement capability, and so they're not used in high movement applications. In the next few slides, I'm going to be going a bit deeper into the other three sealant chemistries listed here. So that's silicones, polyurethanes, and hybrid technologies. Starting off with silicones. So when it comes to silicones, we could generally classify them in two different ways. That's acid cure silicones or acetoxy silicones and neutral cure silicones. Acetoxy silicones release acetic acid when they cure. So they're strongly associated with a distinctive vinegar-like smell when they cure. Some benefits of the acetoxy silicones is that they are inexpensive, they cure at a faster rate than neutral cure silicones, and they do have excellent adhesion to certain substrates like glass and ceramics, for example. A limitation of acetoxy silicones is that the acidic byproducts that are released during cure can be corrosive and can damage or stain certain building substrates. So they're not suitable, for example, on porous substrates or raw metals. Neutral cure silicones release alcohol or other non-acidic substances as the cure. They will typically have low to no odor. They offer several advantages to acetoxy silicones, including better adhesion to a wide range of building substrates, being able to be used on porous as well as non-porous substrates. They also have better weather resistance and movement capability when compared to acetoxy silicones. Within the family of neutral cure silicones, sealants, these can be broken down again into two further sealant chemistries. So just briefly on this, we won't try and overcomplicate it, but neutral cure silicones can be either alkoxy or oximes. The difference between these two chemistries, alkoxy silicones release alcohol during cure. They are low odor and have lower VOC content. Oxime silicones release MEKs or methyl ketones during curing. You don't need to remember that, but they're essentially MEKs are just an example of VOC, which we covered earlier. So their release can lead to oximes having a more noticeable odor when compared to alkoxies. Oxime silicones do have the advantage of being faster curing than their alkoxy counterparts. Let's look at some of the benefits there are when selecting a silicone sealant. So firstly, silicones are an inorganic sealant, so they are unmatched when it comes to their weathering and aging resistance, and in particular, their resistance to UV. Now, it's for this reason that they're the only sealant approved for use in certain high-performance applications, such as structural glazing. Silicones are also unmatched when it comes to the resistance to temperature extremes, both in terms of their resistance to temperature variations once they're cured, but also their ability to be able to be used and gunned at a wide range of temperatures, including sub-zero temperatures. Silicones have very good adhesion to a wide variation of common building substrates, especially non-porous substrates such as glass and metals. Polyurethanes are one of the older sealant technologies that have several advantages, but also a few limitations. They tend to be economical. They show excellent adhesion to porous substrates such as concrete and masonry, and they have a good degree of movement capability. So they're suitable for expansion and moving joints. A key advantage that polyurethane sealants have over silicones is that they are paintable, where silicones are not. Some of the limitations of polyurethanes include that being an organic sealant, they don't have the same UV resistance as silicones do. So if used in exposed or external applications, they can break down and harden over time. Polyurethanes also contain isocyanates, which is another VOC released during cure, which can be harmful. Finally, in the section, we look at hybrid sealants. Now, hybrid sealants are a more recent development compared to your traditional polyurethanes and silicones. The language used to qualify hybrid sealants can get a bit confusing. So you may see these referred to as SMPs or silyl modified polymers or silyl terminated polymers. You may see them referred to as MSs, modified silicones, or you may see them referred to simply as hybrid sealants. While there are definitely differences between these sealant chemistries, they're not all the same. How they fit under the umbrella of hybrids is that they are all modified engineered polymers. And the design of hybrids generally is to take some of the advantages of silicone sealants, so the weathering UV resistance benefits, with the paintability of organic sealant technologies, such as polyurethanes, for example. As the technology has developed over time, newer hybrid sealants have been developed, which have removed unwanted VOC components like the isocyanates. In this next section, we will cover some of the key factors that you need to consider when selecting a sealant, looking at both key sealant properties as well as specific application considerations. One of the first questions to ask yourself, or one of the first questions that we might ask you when we're posed with a question, what sealant should I use, is what are you trying to stick to? So when selecting a sealant for an application, you need to know what substrate or substrates the sealant will need to adhere to. Now, past experience may provide a good indication if a particular sealant type can be expected to achieve good adhesion. Product technical data sheets are also a very good resource. These will usually detail common substrates which the sealant is suitable for. Note that for bonding or structural applications, appropriate structural sealants or adhesives should be considered. While we normally consider sealant adhesion first and foremost, we cannot ignore compatibility. So when incompatibility between a sealant and a substrate or between different sealants is present, it normally presents as noticeable sealant discoloration in minor cases, which may be no more than an aesthetic issue. In severe cases of incompatibility, the mechanical properties of the sealant may be affected, resulting in sealant hardening or eventually adhesion loss. For many common building substrates that we're familiar with, the prospect of sealant incompatibility is not a concern. In saying that, every now and then you may come across certain substrates, usually chemical coatings or waterproofing membranes, where compatibility cannot be assumed. There may also be instances where sealants are being specified in areas where different sealing products and chemistries are being applied within the same vicinity, where compatibility should be considered. If you do come across a substrate, perhaps a branded flashing membrane, for example, or a waterproofing coating that you're unfamiliar with, and you have questions on the expected adhesion and compatibility, you can ask us. There's a chance that we will have carried out lab testing on that substrate before and have test reports on hand. Now, we do maintain a library of test reports for common building substrates, which we're adding to all the time. In case we haven't tested the material before and the project requirements demand that some formal testing be carried out, we can assist you in getting this done. We facilitate lab testing with some of our key sealant suppliers, so Dow, Bostik, and Tremco. We can test for adhesion, compatibility, and staining. Finally, and very importantly, the last point I'll make on this slide is that we always recommend that for every project, site-specific adhesion testing is carried out to verify that good adhesion can be achieved between the sealant and the substrate in real-world conditions. So this is the case regardless if it's a substrate you've worked with in the past, regardless if it's a product that we have a formal lab report on. There will always be variation that can't be accounted for. This is a very simple QA test that can verify that a good adhesion can be achieved. After you are confident that the sealant that you're considering will be able to adhere to the relevant substrate, the next factor that we normally consider is movement capability. So joint movement can be caused by several different factors, including wind loading, vibration, seismic movement, and thermal expansion and contraction of substrates. Understanding what degree of joint movement is expected in your application will allow you to select a sealant that has the sufficient movement capability to be able to withstand this expected movement. The application, substrates you're working with, and location where the sealant is being installed will all have an effect on the movement you need to design for. Obviously, an external expansion joint will require much more movement than an adhesive sealant being used to fix a mirror, for example. In the product technical data sheets, movement capability will often be expressed in the form of a percentage, given as a percentage of extension and compression of the sealant. Finally, when designing a joint for sealant movement, standard joint design principles must be applied to ensure that the joint can accommodate the movement specified in the product technical data sheet. Sealants are often referred to as low modulus or high modulus, but what does that term actually mean? So when we talk about the modulus of a sealant as a physical property, most often we're referring to the elastic modulus or the modulus of elasticity. The elastic modulus of a sealant is a value which describes the amount of tensile force required to stretch or elongate a sealant. So low modulus sealants require less force to achieve substantial elongation. As a result, they will tend to feel softer and stretchier. Low modulus sealants are suitable for use in expansion joints where high movement needs to be accommodated for. At the other end, high modulus sealants require a larger amount of force to induce sealant elongation. They will feel harder and more rigid. High modulus sealants are more likely to be used as bonding adhesives or structural sealants. The additional hardness also makes them more resistant to puncture and abrasion, making them more suitable for use in applications subject to additional mechanical force, such as trafficable sealant joints or non-PIC sealant applications. Another sealant property that you may hear discussed or you may see detailed in a product data sheet is slump. Now, slump is a property that describes how well a sealant holds onto a wall or surface when applied in a vertical installation. A sealant with excessive slump will start to sag and slide downward when applied, making it difficult to tool off. After you're satisfied that you know what mechanical properties a sealant is required to satisfy, you can consider what aesthetic qualities you require from the sealant. Here you can look at the available color range of your required sealant. The most common sealant colors will tend to be black, gray, and white, and for certain applications, translucent or clear. If you do require a sealant that is paintable, we always recommend to conduct your own confirmatory testing to ensure that whatever prescribed paint system achieves the desired adhesion and finish on the cured sealant. Sealants will always have a degree of flexibility, so it's important that any paint system being used is able to tolerate that movement to avoid cracking of the paint film. Now, in this last section, I'd just like to run through some of the key sealants offered by Glasscorp. So this is by no means covering all the sealants, but just some of the key ones. At Glasscorp, we are agents for some major global sealant suppliers, including Dow, Tremco, and Bostik. We also sell a few sealants produced especially for us under the Glasscorp brand. Starting with Dow sealants, so these are some of our Dow structural glazing sealants. So you've got Dowsil 983, which is our two-part structural glazing silicone used in factory settings. This requires the use of a mixing pump to apply. For on-site structural glazing, we have two options. So Dowsil 121, which is a portable two-part option. We supply pneumatic and electric dispensing guns to use with Dowsil 121. And finally, Dowsil 795, a one-part structural glazing sealant, a good 50% movement capability. We supply this in sausages and cartridges. The next level down, we've got some of our Dow weather sealing silicones. So you've got Dowsil 688, which is a good workhorse when it comes to general construction glazing weather sealing applications. Dowsil 791, which is a premium weatherproofing silicone, that higher movement capability of 50% being the key difference. And Dowsil 790, which is a ultra low modulus construction silicone with 100% extension, 50% compression, very specialized sealant used in certain high movement applications. Here you've got some more specialized products. So Dowsil 758 is a weatherproofing silicone, specially designed for low energy surfaces. So when you've got certain membranes, for example, that are very hard to stick to, certain plastics, Dowsil 758 will tend to come in as an option when the other sealants might struggle to adhere. Dowsil 896 is a prescribed system combining sealant and tape. This is used for panel bonding applications. It's one of the newer products in our range. Moving on from silicones, so these are a few hybrid sealants in the Glasscorp range. So you've got HP Facade, which is a polyurethane-based hybrid. Good for a lot of your general facade applications. It's got very similar properties to a product you might be familiar with, Sika 80 Facade. And we also have MSHP, which similar applications, perimeter sealing, general construction seals. This is the SMP sealant technology, so a hybrid with a more silicone base. Both of these sealants have 25% movement. They're both brands appraised. They're both low VOC, and they're both paintable. Dimonic FC, which is a polyurethane-based hybrid sealant from Tremco that we supply. Good movement capability, good option for construction joints and expansion joints, very good adhesion to porous substrates. And like our other hybrid sealants, this is also a paintable sealant as well. And finally, some sealants in our Bostik range. So we've got Bostik V60, which is a silicone, weatherproofing silicone, but also can be used in certain approved structural glazing applications. Bostik 7008, so this is a windscreen SMP adhesive, very high green strength. So green strength, it gains its adhesion properties very quickly. And finally, 7003 and 7005. So these are both Bostik hybrid sealants. 7003 is a good mix between an adhesive and a sealant. So we supply this, for example, in mirror fixing applications, but it's also a good general sealant used in window perimeter applications, for example. Bostik 7005, on the other hand, is a stronger adhesive sealant. So this would be a preferred choice for applications such as panel-to-panel bonding or general bonding applications where mechanical fixings aren't desired. That now brings us to the end of the presentation part of the presentation. So if there are any questions, now would be a good time to send those through. We do intend to follow up this presentation with some more resources, just generally app selection guides, which have some of the different properties of the different sealants to make it easier to select the sealant that's suitable for your application. Otherwise, that is the end of our presentation. So thank you very much for your attention.